Okay, on the Math 4 exam review, we're now on problem 23A. They're asking us to solve the equation using completing the square. That's just one of the methods for solving a quadratic equation. So the first thing I want to do is remember that I need space to figure out what number would be right after this one to make this a perfect square trinomial. Perfect square trinomial means you have two identical factors. So I'm going to rewrite x squared plus 18x plus space for the number that I'm going to use equals negative 72 plus, again, space, because whatever I add to this side of the equation I have to add to this side in order to keep my equation without changing its value. So the rule for completing the square is make this number be something that allows me to factor this trinomial to two identical factors. And the way we do that is we take half of that middle coefficient, half of 18, which is 9, and then square that. 9 squared is 81. And anything I add to the left-hand side of the equation, I have to add to the right-hand side of the equation so that they are still equivalent. You don't need to write this part out. You can do that in your head. So then when I go, at this point, all I'm really doing is factoring this. I'm looking for what multiplies to 81 and adds to 18, which should be two identical factors, and it is. 9 times 9 is 81. 9 plus 9 is 18. So when you go to write it in factored form, if you worked this correctly, you don't have to actually go back and factor it. You can take the square root of the first term and this number and this sign, so that's x plus 9 squared. And if you multiply that out again, you do get x squared plus 18x plus 81 equals, add this side and you get 9. So now we're going to use extracting square roots. Because this is squared, I want to take the square root of it and the square root of the other side. And remember, anytime you take the square root of a squared term, the square root of the other side, you have to acknowledge that this could be positive or negative. So this becomes x plus 9, and that's plus or minus 3. So now I'm going to subtract 9 from both sides, and that gives me x equals negative 9 plus or minus 3. So I have to do both of those cases, and of course it's a quadratic equation, so it should have two solutions. So my first one comes from negative 9 minus 3, which is negative 12, and my second one comes from negative 9 plus 3, which is negative 6. So my solutions are negative 12 and negative 6. And I always put my solutions in order from least to greatest, littlest to biggest. And so those are my two solutions in set notation, which is braces. Okay, this one is a little bit more complicated because remember, when you're completing the square, the rule is you need to have a leading coefficient of 1. I have a leading coefficient of 2. So I'm going to handle that by dividing everything through by 2. Some of you, if you recall, learned this previously and you factored out the 2. If that's the method you like, you're certainly welcome to use that method. I'm going to follow the method that our textbook does and divide through by 2. So that now gives me x squared plus 5 over 2x plus whatever number it's going to take to complete the square equals 3 over 2 plus whatever number that is it's going to take to complete the square. So remember, the rule is I take half of that middle number, or the coefficient of the linear term, half of 5 halves. That gives me 5/4. Square that term, and that gives me 25 over 16. And I add it to both sides. So now I need to factor this trinomial. Remember, it's the root of the first, the sine of the middle, whatever half of that number was, which is 5 over 4. You could also say what two numbers multiply to 25 over 16 and add to 5 over 2. So here I go. I square it, and now I need to add those fractions, which means they have to have a common denominator, which would be 16. 2 goes into 16. 8 times 3 is 24, plus 25 over 16, of course, gives me 49 over 16. Now, because this is squared, I'm going to take the square root of both sides, which gives me x plus 5 over 4 equals plus or minus the square root of 49 is 7, and the square root of 16 is 4. So again, I'm going to subtract 5 over 4 from both sides, and that gives me, these cancel out, x equals negative 5 over 4 plus and minus 7 over 4. Negative 5 fourths minus 7 fourths is negative 12 fourths, and negative 12 fourths is negative 3. Negative 5 fourths plus 7 fourths, negative 5 plus 7 is 2. 2 fourths is 1/2. Didn't show all the work there because I was trying to conserve some space. So those are my answers, negative 3 and positive 1/2. Again, negative 5 fourths minus 7 fourths was negative 12 fourths. That's where my negative 3 came from. Negative 5 fourths plus 7 fourths was 2 fourths, and that's where my 1/2 came from.